Myself, Dr. Somit De, teacher in charge and assistant professor of mathematics section under Department of Basic Science and Humanities. This is second lecture from the topic diagonalization of a matrix. So that's why I'm using two. Okay, the paper name is Mathematics 1A, paper code BSM-101. This subject belongs to BTech first semester under the branch Computer Science and Information Technology. In my first lecture of this diagonalization matrix, I had discussed similar matrix and what are the conditions what are the conditions by which we can say what is the condition by which you can say the corresponding matrix is diagonalizable matrix. So number one is if the diagonal eigenvalues are same, if eigenvalues are different, if eigenvalues are different, then we can say the corresponding matrix is diagonalizable. If the next question is why, because if diagonal values are eigenvalues are different, automatically then there exists a different eigenvector. So that means your eigenvector are linearly independent. If the eigenvector are linearly independent, then automatically we can find the P matrix. That means we can convert the corresponding matrix to a diagonal matrix. Okay, in last lecture I had I was used one 2 cross 2 matrix. Okay, in this lecture I will discuss whether the given matrix is diagonalizable or not with the help of 3 cross 3 matrix. Let's see. If possible, diagonalize the matrix A 2 1 2 2 1 1 3 1 1 2 2 and find matrix B which diagonalize A. Okay, what is the difference? In last example it was only 2 cross 2, now it is 3 cross 3. So there any type of question you can see in your university paper, either 2 cross 2 or 3 cross 3. Okay, let's see. The given matrix A is equals to 2 2 1 1 3 1 1 2 2. We need to check the eigenvectors of A. If A is diagonalizable, then it has we need to check the eigenvector of A. If A is diagonalizable, then it has 3 linearly independent eigenvector. Let's see. Therefore, A minus lambda I, this is your A matrix, that is 2 2 1 1 3 1 1 2 2 minus lambda 1 0 0 0 0 1 and 0 0 0 1 0 and 0 0 1. This is identity matrix. What is lambda? Lambda is a scalar quantity. So if I simplify, what you have, 2 minus lambda 2 1 1 3 minus lambda 1 1 2 2 minus lambda. The characteristic equation is determinant A minus lambda I is equals to 0. So from here you may write 2 minus lambda 2 1 1 3 minus lambda 1 1 2 2 minus lambda as a determinant is equals to 0. Already know how to expand the determinant, 3 cross 3 determinant. The 2 minus lambda, that is 3 minus lambda into 2 minus lambda minus 2 minus 2 2 minus lambda minus 1 and 1, that is 2 minus 3 minus lambda. After simplification, what we have, 2 minus lambda after multiplication of this, lambda square minus 5 lambda plus 4 plus 2 into lambda minus 1 plus 1 into lambda minus 1 is equals to 0 from this. That is 2 minus lambda minus 1, that is using middle term factor technique. Okay, that is lambda minus 2 minus lambda minus 1 lambda minus 4 plus 3 into lambda minus 1. So from first line it is clear that lambda minus 1 is common, so you may write lambda minus 1 lambda minus 2 lambda minus 4 and 3. So here adjusted. Suppose you have a doubt why it is negative, because here it is 2 minus lambda, I have shifted to lambda minus 2, 1 minus adjusted in this line. So what you have after that, so that's why I'm using multicolor for a better understanding. Okay, if you have a doubt, then I can explain, no problem. Try to understand, very easy. Try to understand, very simple. That is lambda minus 1, that is 2 minus lambda, lambda minus 4 plus 3 equal to 0. So if I take lambda minus 1, that is if I write minus of lambda minus 2, lambda minus 4 plus 3 equal to 0. So if I take minus common, that is lambda minus 1, lambda minus 2, lambda minus 4 minus 3 equal to 0. So in next line automatically these are multiplied, this negative sign will absorb. Okay, so ultimately what we have, lambda minus 1, lambda minus 2, lambda minus 4 minus 3 equal to 0. So that's why I have this. Okay, this is the logic behind this. Now after simplification, what you have, lambda minus 1, that is lambda square minus 6 lambda plus 8 minus 3 is from here. So you have lambda square minus 6 lambda plus 5 equal to 0. If I use multiple factor, middle term factor, then what you have, lambda minus 1, lambda minus 1, lambda minus 4 equals to 0. So from it is clear that their eigenvalues lambda of A are 1, 1 and 5. So here I have two like eigenvalue. Let's see, where can you identify a diagonal matrix, yes or no? Clear? There are two eigenvalues, sorry, 1, 1 and 5, basically 1. Let lambda is equals to 1, for lambda is equals to 1, let x is equals to x1, x2, x2, x3 be the eigenvector corresponding to the eigenvalue lambda is equals to 1. That is a minus lambda I x is equals to null vector. So you may write 2 minus lambda, 2, 1, 1, 3 minus 1, 1, 1, 2, 2 minus 1, x1, x2, x3 and 0, 0, 0. So from it is clear, after simplifying what we have, 1, 2, 1, 1, 2, 1, 1, 2, 1, x1, x2, x3 and 0, 0, 0. Clear? After substituting the lambda value. So after multiplication, what you have, x1 plus 2x2 plus x3, x1 plus 2x2 plus x3, x1 plus 2x2 plus x3 equals to 0. So from it is clear, basically we have single equation. Three are same, correct? So we may write x1. So we may write x1 plus 2x2 plus 2, x3 equal to 0. Now how many equations you have? One equation. How many variable you have? Two, 3 variables you have. In that case, if I have tried to understand, is very interesting point. You should memorize. One equation, two variable, that is number of variable should be that is one equation, two variable. If I have, then we should write 2 minus 1, that is 1 is equals to k1. Okay, in last, that is in last lecture you can check, but here you have one equation, 3 variables, correct? So that means 3 minus 1 is equals to 2 variable choice. You have to choose 2 variable. So this 2 variable is total depends on your own choice. So you have, it means you have to choose 2 variable. Now, so that's why I'm taking x2 is equals to k1 and x3 is equals to k2. Clear or not? For this reason, one equation 3 variable, that is 3 minus 1, that is 2 variable should choice. So here I'm considering x2 is equals to k1, x3 is equals to k2. Suppose you have a question in your mind, sir, can I consider x1 x2? Yes, why not? Can I choose x1 x3? Yes, you can, no problem. So when I substitute the value x2 is equals to k1 and x3 is equals to k2, from x1 what we have, minus x1 2x1 2k1 minus k2, where k1 comma k2 are non-zero real constant. Okay, therefore the required eigenvector for lambda is equals to 1 is, so this line is very important, try to understand. This is very important. X is equals to x1 x2 x3 is equals to, what is x1? Minus 2k1 minus 2k minus k2. What is x2? K1. And what is x3? K3. Now try to understand how to rewrite this, okay, very easy. Try to understand. Mm, basically minus 2, so here you may write 0k2. So here you may write 0k1 plus this. Can you write? Yes. Okay. Now tell me, but is 0 into something means no effect. Now in this line what is missing? K2 is missing. So that's why I'm writing 0 into K2. In say third row, what is missing? K1 is missing. So that's why I'm adding 0 into K1. Okay, try to understand. Very easy. Now we check what is the coefficient of K1. What is the coefficient of K1? Minus 2. What is the coefficient of K1? 1. What is the coefficient of K1? Is 0. So that's why I'm writing minus 2, 1, 0. K1 multiply with minus 2, 1, 0. Clear? Similarly, plus K2. What is the coefficient of K2? Minus 1. What is the coefficient of K2? 0. What is the coefficient of K2? 1. So that's why I'm writing minus 1, 0, 1. So from here it is clear, for eigenvalue lambda 1, there exists eigenvector x is a linear combination of these two vector 2, 1, 0 and minus 1, 0, 1. Okay, clear? So this is the logic behind this. Suppose you have a question in your mind, from where you have this? So this is the logic behind this. First you have to write down what is your x1, what is your x2, what is your x3. Then you check each and every row which part is missing. So that part you should express as a 0 into something. Okay, so therefore for a non-zero real values of k1 k2, there were minus 2, 1, 0 and minus 1, 0, 1 are two eigenvector corresponding to the eigenvalue lambda is equals to 1. Now lambda is equals to 5. For eigenvalue lambda is equals to 5, let y1 y2 y3 be the eigenvector corresponding to the eigenvalue lambda is equals to 5. Then a minus lambda I y is equals to 0. Now substitute 2 minus 5, 2, 1, 1, 3 minus 5, 1, 1, 2, 3, 2 minus 5, y1, y2, y3, 0, 0, 0. So that means everywhere you should replace lambda by 5. Now what we have? Minus 3, 2, 1, 1, minus 2, 1, 1, 2, minus 3, y1, y2, y3. Now what if we simplify what we have from the first row? Minus 3y1 plus 2y2 y3 plus y3 equal to 0. From second, y1 minus 2y2 plus y3 equal to 0. y1 plus 2y2 minus 3y3 is equals to 0. Now from here it is clear that all three equations are different. There is no common. So that's why three equation, three unknown. So you can use different method. Here in this case I'm using cross multiplication technique for first two equation. First you have to check whether can I find the value of y1, y2, y3 from past two equation. Then after getting the value, just you have to check whether this equation is verified or not. Okay. Now from first equation y1, so already you know the cross multiplication technique. 2 into 1 minus of minus 2 into 1 is equals to plus is equals to y2 minus common first outside. Now using cross multiplication, the minus of minus 3 into minus 3 into 1, this into that. Okay. And 1 into 1 is equals to y3, that is minus 3 into minus 2 minus of 1 into 2. So after simplification you have y1 by 4, y2 by 4, y2 by 4 and y3 by 4 after simplifying. So 4 are common, so you can cancel it. Then y1 by k1, y2 by 1, y3 by 1, that is these are our ratio. You may consider k3. So y1 is equals to k3, y2 is equals to k3, y3 is equals to k3. If I substitute here, okay, so from here it is clear. If I substitute here, let's see, if I substitute here, just to check, y1 y1 is equals to k3, y2 is equals to k3, y3 is equals to k3. If I substitute all in this equation, what we have, that is k3 plus 2k3 minus 3k3, ultimately 0 after simplification. So from here it is clear this value y1, this value satisfies this relation also. Okay, satisfies this relation. So from here it is clear y1 is equals to k3, y3 is equals to k3 and y3 is equals to k3. Therefore the required eigenvector for eigenvalues lambda is equals to 5 is y3, y is equals to y1, y2, y3, k3, 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 that is k3 is equals to 1, 1 and 1. Now since the eigenvector x and y are two linearly independent, since three eigenvectors are linearly independent vector, therefore the given matrix can be diagonalized with the help of the matrix P, that is 2, 1, 0, minus 1, 0, 1, 1, 1, 1. Same logic from where you have this, what is x? X is equals to x1, x2, x3. This is a linear combination of these two vectors, that is minus 1, 1, 0, first column, minus 1, 0, 1, second column, and 1, 1, 0 is the third column. Therefore, the diagonal form of the given matrix A is given by D is equals to P inverse AP, that is 1, 0, 0, 0, 1, 0, 0, 0, 1. What are the diagonal eigenvalues? 1, 1, 0. So that's why you should write 1, 1, and 5. What are the eigenvalues? 1, 1, 5. This 1 and 1, the first column and second column, are the eigenvector for lambda, eigenvalue lambda is equals to 1. Okay, for this reason. Now let's verify. P is equals to this. Now AP is equals to A into P. If I multiply, you can generate this -2 -1 5 1 0 5 0 1 5. What is our target? Our target to convert this expression as a product of first column is a product of 1. That is 1 into -2, 1 into 1, 1 into 0. Second column is a product of 1. That is 1 into -1, 1 into 0, 1 into 1. That is third column, that is 5 into 1, 5 into 5 into something, that is 5 into 1, 5 into 5, 1, 5 into 1. Clear? Now check, I am using multicolor for a better understanding. That is all multicolor part is come to the here. That is first column you should write here 1 0 0. From second column 1 is replaced by 0 1 0, and third column 5 is written by 0 0 5. Okay, but if what is the non-blue color element, that is -2. If I consider column wise, -2 1 0, -1 0 1, 1 1 1, you write as a matrix. Okay, so what is this? This is a P matrix. What is this? This is a diagonal matrix. So already you know, if I can express AP is equals to, if I can express AP is equals to AP is equals to PD, then automatically we can write D is equals to P inverse AP. Okay, so therefore the diagonal form of the given matrix A is given by D is equals to minus P inverse AP, that is 1 0 0 0 1 0 and 0 0 5. So here your main part, when you multiply AP, our next target to express, so this is the main vital part, to express according to the eigenvalue wise. This first column 1 means the first eigenvalue. Second column 1 is a second eigenvalue, and third column 5 is third eigenvalue, that is 5. Okay, thank you. Similar type of problem try to solve. Okay.